So we have talked about solving equations, one step, one step, two step, multiple steps. And so we want to take that further, and we will do more multiple step actually, and talk about consecutive integer problems. So if you think about what the word consecutive means, like if you go to the park 5 consecutive days, that means 5 days in a row. So a set of consecutive numbers might be 1, 2, 3, 4, 5, because they're all in a row. So we've got consecutive integer problems. So we also need to address what the word integer means. And so if you remember when we made our chart of our real number system, the integers were negatives, the positives, and 0, but whole numbers, and they are here in the blue circle. So we are looking for whole numbers. If you get an answer that's not a whole number, then you did something wrong. So you want to make sure that you remember that. And if that is the case, you need to go back and fix it, of course. So we have different types of consecutive integer problems. We have consecutive, we've got consecutive even, and we've got consecutive odd. Now, we already did talk about in the Cornell notes, and if you haven't watched that video, you might need to watch that, about how you can set up a consecutive integer problem using x plus 1, x plus 2. Or if it's a consecutive odd or even, remember, because you're skipping over, you are always adding 2, adding 4, whether it's even or odd. So you always begin with x, and then for an odd or an even, you're going to skip over the next number, so then it brings you to x plus 2, and then skip over the next number, which brings you to x plus 4. So if you need more explanation for these, you can go to your Cornell notes for the section 3.4b or 3.4, I guess. So in this first problem, it says the sum of 3 consecutive integers is 69. So we know we're looking for 3 integers, and it's good to make sure you focus on that, because sometimes I have students that get them wrong just because they put the wrong number of integers in at the beginning. So the first integer is always going to be represented by x. Now these are consecutive in order. So the next one would be x plus 1, and the next one would be x plus 2. And it says the sum of these is 69. So the easiest way to do this, not the only way, but the easiest way is just to add them down. So if we want to find the sum of these 3, we add them down. So x plus x plus x is 3x, and 1 plus 2 is 3. And we know the sum, when we add them together, should be 69. So there's our setup, and here's our equation now. 3x plus 3 equals 69. And now we'll just use what we know about solving equations to find out what x is. So of course we want to undo addition and subtraction first, so we subtract 3. 3x equals 66. And we need to get x alone, so we divide both sides by 3. So we get x equals 22. First, we are going to write a sentence eventually. But what I'd like you to do then is to take the 22 and plug it back into each of these expressions to figure out what these 3 numbers should be. So x is, of course, 22. X plus 1 would then be 22 plus 1, which is 23. And then x plus 2 would have to be 22 plus 2, which is 24. Now these, as well as some other types of word problems, can easily be checked. If you just add them down, do you get 69? And if you add those together, we do. So we know that we got it right. Now this is a word problem, so you have to write a word sentence at the end. The integers are 22, 23, and 24. All right, let's try another one. Number 2 says the sum of 4 consecutive integers is negative 106. So this time we need to set up 4. So still the first one is x, x plus 1, x plus 2, x plus 3. And we're still looking for the sum of them. So we'll add down once again. X plus x plus x plus x is 4x. 3 plus 2 plus 1 is 6. So we get 4x plus 6, and the sum of those is equivalent to or equal to negative 106. So I'm going to rewrite that up here. We want to solve, so we undo addition and subtraction first. So we subtract the 6. Be careful right here with your signs. This is really negative 106 minus 6. So negative 106, leave, change opposite. So it would be negative 106 plus a negative 6, which is going to be negative 112. We want to get the x alone, so we divide both sides by 4. And we get x equals negative 28. So let's plug this back in and see what we get. X is negative 28. You have to be careful here. Generally they go up, but when they are negative, even though they are going up, they will seem as though they're going down, because when you add negative 28 plus 1, you don't get negative 29, you get negative 27. And then you get negative 26 and negative 25. So when we add these together, again, check that before you write your sentence so that you are sure that it is correct. But when we add these together, we do get negative 106. So the integers are negative 28, negative 27, negative 26, and negative 25. All right, the next one, the sum of 3 consecutive odd integers is 75. So this time we're talking about 3, but we're talking about odd integers. So we still begin with 1. The first one's always x. But since it's odd integers, we're going to skip the x plus 1, which will bring us to the x plus 2. And then we're going to skip the x plus 3, which will bring us to the x plus 4. Because remember, if they're odd, like 1, 3, and 5, you're skipping over a number. So you're still adding 2 to get to the 3, and then adding 4 to get to the 5, which is where this 2 and 4 is coming from. So make sure you're not using x, x plus 1, and x plus 3. It's about skipping over that makes them even. They're always going to be 2 and 4. Whether it says odd or even, it's always plus 2 plus 4. The sum in this case is 75, so x plus x plus x is 3x plus 6 equals 75. We want to solve, so we want to undo addition and subtraction. Subtract 6 from both sides. 75 minus 6 is 69, and we divide by 3. We get x equals 23. Now remember, in these notes, I'm going more quickly than I would if we were in class. But that is because you can pause it and rewind it anytime you want. So if you're having any trouble, you go ahead and rewind it and play it again so that you understand it. Now let's double check. First of all, is this odd? Yes. So we're good. We might be good. That's the first step. Now let's plug these in and see what they are. X is, of course, 23. 23 plus 2 would be 25. And 23 plus 4 would be 27. So we did get consecutive odds, and we want to make sure they add up to 75, which, of course, they are going to add up to 75. So the integers are 23, 25, and 27. So these are your basic consecutive integer problems. And then number 4, I actually had to go ahead and change. I forgot to change this. And this is going to be a little more challenging than these basics where you're just finding the sum. So let's first adjust this problem. I want you to change it to find 3 consecutive integers instead of 2, such that the sum of the largest and 5 times the smallest is negative 244. Okay, rewind that if you need to. But first of all, we need 3 consecutive integers. So we've got x, x plus 1, and x plus 2. Now, in these problems where they're talking about the largest and the smallest, for me, I understand which one is the largest and which one is the smallest. But for you, as you begin these types of problems, you may want to identify which one would be the smallest. Of course, this x would be the smallest, because when we add things to it, it's going to make it get bigger. So let's call this small. We can call this medium. We'll call this one large, just so it makes the translating step a little bit easier. Now this one's not a straight up sum, so we're not going to just add down and set it equal to negative 244. It says the sum of the largest and 5 times the smallest. So it's saying if we take the largest and we add it to 5 times the smallest, that is negative 244. So I haven't actually put these in here, but I'm translating this into an equation. The sum of the largest number and, that's plus, 5 times the smallest, SM for small, is, tells us equals, negative 244. Now we can plug in what we know the large is. The large is x plus 2. And the small is x, which you can just put 5x. And then you're just solving the equation. So generally, you just need to take it step by step. Translate it if you want first into words, a wordy equation, I guess, and then put in your actual integers. So we need to combine like terms over here. We could do that at the same time as moving the 2 over. So we'll go ahead and subtract the 2. So we get negative 246. And we can combine the x and the 5x to get 6x. So we want to solve for this. So we're going to take the 246 and divide it by 6. And so we get x equals negative 41. Now we still want to check this. So let's go plug in our numbers over here. X would be negative 41. X plus 1, remember, would be negative 40 because we're adding 1 to it. And x plus 2 would be negative 39. Now to do a check on this one would not be the same as the check here because we're not just going to add down. We have to actually see if this is true again. The sum of the largest and 5 times the smallest. So the largest is negative 39 plus 5 times the smallest. So we have to do 41 times 5, which is going to be negative 205. Okay, so we take the smallest and multiply by 5. When we add that together, we do get negative 244. So we're good. So the integers are negative 41, negative 40, and negative 39. All right, so that's it for consecutive integers. We'll practice more of that in class. And we want to move on to multiple step equations. Here we go. All right, now, remember, on your Cornell notes, you already have steps written down. So we want to follow these steps every time. We want to distribute first, then combine any like terms, like the 15 and the 5 here, before you start moving anything by undoing addition or subtraction, undoing multiplication and division. So always distributing. This is the step right here that is skipped sometimes, combining like terms. So make sure you do that before you move on. All right, it'll also shorten the work that you have to do if you combine them first. So we see the parentheses here. We need to get rid of those parentheses, so we're going to distribute. You cannot add 5x plus 3 for multiple reasons, so make sure you're doing the distribution first. So the 5x is just going to come down. 3 times x is 3x, and 3 times 4 is 12. Okay, so distribute, combine like terms, undo addition and subtraction, undo multiplication and division. So those are the steps that we want to use. So we need to do combining like terms. 5x plus 3x is 8x. Now we can undo addition and subtraction. So the opposite of adding 12 would be to subtract 12, which is going to give us 16. And then undo multiplication and division. So we're going to divide by 8, and we get x equals 2. Now remember, we are putting these in set notation. So x such that x equals 2. All right, I want you to pause the video and try number 6 on your own and then come back and check it. All right, hopefully you've done this one on your own. Let's see how you did. We need to distribute the negative 2. Be careful that you do not distribute it to the x because it is not inside the parentheses. So we get negative 2x, and then a negative 2 times a positive 1 will give you positive 2. So that's distribute. Now combine like terms, negative 2x and negative x, which is going to be negative 3x. And you're going to just bring the 2 down. Now we want to undo addition and subtraction. So the one that is not touching the x always goes next. So instead of adding 2, we'll subtract 2. So we get 17 equals negative 3x. And part of you is probably going, oh, I must have done something wrong. But you actually are on the right track. We want to undo multiplication and division. So we're going to divide by negative 3. And we are, in fact, going to get a fraction. And that's not a big deal. So this is x. And you can either leave it as 17 thirds, negative 17 thirds, or you can change it to negative 5 and 2 thirds. That's up to you. But when you put it in set notation, you have to actually flip it over. X such that x equals negative 5 and 2 thirds. I do not require that you change it from an improper to a mixed. So if you're not comfortable changing it to a mixed, then the suggestion is to always leave it as an improper. It just needs to be simplified if possible, and that can't be simplified. So either this answer or that one would be fine. All right, a couple problems with fractions. Actually, multiple problems with fractions. So we talked about when you have fractions, you want to get rid of them by multiplying every term by the denominator. So in number 7, we've got 1, 2, 3 terms here. We've got a denominator of 2. So we're going to multiply each term by 2. So times 2 over 1 times 2 over 1. So if it's a whole number, I just use the whole number. If it's a fraction, I use a fraction. So 3y times 2 would be 6y. These cancel, so we're just left with minus 1. These 2's will cancel, and we're left with 1y. Voila! No fractions, so we can continue on through this one. Now we want to get the variables together, and this is actually a foreshadowing of a future section because we have variables on both sides. So as you expected, we want to get them variables together. This is a little more challenging because it is a kind of using an idea we haven't covered yet. So we want to move this 6y to the other side so all the y's are together. So we subtract the 6y just like we would subtract the 12 in that previous problem here. Okay, and those cancel. We're left with negative 1, and 1y minus 6y is negative 5y. All right, we still want to get y alone, so negative 5 times y. The opposite of that would be to divide by negative 5. And so we're left with 1/5. Now at this point, if you want to go ahead and flip it over, y such that y equals positive 1/5. Now remember, a negative divided by a negative gives you a positive, so that's to be a positive 1/5. Now this you will not see on your homework tonight because this is, like I said, variables on both sides. It's what we're going to cover tomorrow. So you won't see that. So if you're a little confused by that, don't worry, we'll practice that more. But 8, we should be able to do with no problem. So why don't you pause the video and see if you can do that one on your own first. You can also go ahead and do 9. So please pause and do 8 and 9. All right, let's see how you did. Now we have a denominator of 3, so we want to multiply everything by 3, or 3 over 1. So 8x times 3 would be 24x. In the next problem, the 3 on the bottom and the 3 on the top cancel, and we just get minus x. And 46 times 3 is 138. So we distributed. Now we can combine these like terms, 24x minus x. Remember that's minus 1x. That gives us 23x. And then we need to get x alone. So instead of multiplying by 23, we'll divide both sides by 23. And we get x such that x equals 6. That one is a two-step equation, I guess. But it's kind of a different type of two-step because you have to combine like terms. So that's why it's here and not on the previous day. All right, and hopefully you did number 9 and you tried that one. This one might be a little more challenging. When we distribute the 1/2 times x is 1/2 x. And 1/2 of -4 is -2. So distribute. Now we want to combine like terms. So -2 and +3 can be combined into a +1. All right, you have two options here. You could have done it here, or you can do it here, or you can wait and do it in the last step. You could have multiplied all of these by 2 because the denominator is 2. But remember, there are 4 terms, 1, 2, 3, 4. So all 4 of them would have to be multiplied by 2. Or you can do your combining like terms. Now, in this step, you could multiply by 2. Now there's only 3 terms. Or you can move the 1 over by subtracting it. And then multiply by 2. So it's really up to you in which step you want to multiply by 2. For me, it depends on the nature of the problem. Sometimes I do it right away. Sometimes I do the simpler things first and then get rid of that fraction. So when we multiply 5 times 2, of course, we get 10. And here we multiply 1/2 times 2. The 2's cancel. We're left with just 1x or x. So x such that x equals 10. How'd you do on that one? Is that a good one? All right, number 10, the last one. I want you to try that one also. So go ahead and pause the video and try 10 on your own. All right, hopefully you did it. Let's give it a shot. 1/3 of 6x. So that's just 6 divided by 3. So we get 2x. 1/3 of 9. Again, that's just 9 divided by 3. So that gives us 3. The rest stays the same. So we distribute. Now we want to combine like terms, which is the +3 and the -5. So 3 minus 5 is -2. Now we're going to undo addition and subtraction. So instead of subtracting 2, we will add 2 to both sides. 2x equals -6 plus 2, which is -4. And then we're going to undo multiplication and division. So we divide both sides by 2, and we get x such that x equals -2. So there's your multiple step equations. Follow the steps that are written on your Cornell sheet. Use your Cornell sheet if you get stumped. And always remember, if it involves fractions, that you can multiply through by the denominator to get rid of the fractions. Now, one heads up here. In a problem like 10 or 9, 10 especially, when you distribute the 1/3, the fractions drop out. So don't do anything until you've distributed to get rid of the parentheses, because sometimes when you distribute, the fractions will eliminate themselves. So don't try multiplying through by 3 in the first step here. You're bound to make a mistake somewhere there. So distribute first, and then if there are still fractions, then you might multiply by the denominator at that point.